Hey, good morning. My name is Brett Marquardt, and I'm here to talk about the US FHIR Core. Thank you very much for the opportunity to speak to you today. It's great to share the lessons learned from the States. So first, a bit about me. I'm a principal consultant with Wave 1 Associates. Background is in electronic health record implementation and development, but have spent some time doing standards development with HL7. With the consolidated CDA, did a lot of work with version 2, and most recently with the Argonaut accelerator group working on FHIR. It's fun to be here to be speaking on the US FHIR Core, but understand it's a community behind this. I have just many colleagues, including the support of Graham Grieve, Josh Bendel, Eric Haas, Mickey Tripathi, Dragon, and so I have the honor of presenting today, but it's a whole community effort to produce this type of standard. Before I jump in, it's important to know how is US FHIR Core, had lots of momentum and interest before, but what's made it so exciting in the US right now is our federal government, the group called the Office of the National Coordinator, included US FHIR Core as a requirement that every single EHR or any health system must implement in the near term. Many systems have already started to deploy US FHIR Core, but this will make it a requirement basically within the next 18 months that this will be available for patients. The rule that the Office of the National Coordinator and our government put out is intended to give patients greater access to their medical records and the ability to download and manage it just like they manage all types of other information, digital information. But enough about that, let's talk about the standard. So I'm talking about a little bit US Core and the Argonauts, the importance of profiling, specifically the US Core profiles, a teeny bit about US Core and USCDI. USCDI is the US Core Data for Interoperability. It's a set of core data elements that our ONC has identified, and then a teeny bit about the future. But first, what is the Argonaut project? So within the US, about 2015, there was a group that said API access is critical for improving patient care and helping patients manage their own care. In the Argonaut project, some clinical organizations, some electronic health record technology vendors came together and formed an implementation community to rapidly accelerate the use of FHIR and OAuth. It was a private sector funded activity, worked collaboratively with other organizations, and then created open implementation guides for anybody to use. It was not a new standards development organization, so it was complementary to HL7, not a separate legal entity or proprietary activity. So there was a core niche of people working on it, but all the work, was available to all and accepted feedback from all parties who had a vested interest. These are the folks who are involved. These are many of the major players in the US marketplace and a few key provider organizations. In terms of support staff, many of these folks have been involved since the beginning and are big-time contributors to the international FHIR standard. So what do the actual Argonaut guides do? The first is they tighten the FHIR Core specification. If you have other presenters talk about FHIR Core, it is a large spec. Over 100 resources, lots of search capability, lots of different terminology options. And one of the first things we wanted to do is to make sure we had a common baseline that all systems could support. And so we talked about exactly what search criteria you could use. Are you going to be able to search by patient name, family name, birth date? What are the combinations we're going to allow? How big are the responses going to be? If I want to get all procedures, what does that, what does that search look like, and what does the response look like? And then a very key piece of this is what's the content look like inside? So when I, code my lab results, what terminology is going to be used, or my procedures, or allergies, so that we all speak a common language that will enable client application developers and web developers to access information in a common way. And what did the Argonauts produce? They produced a signature event called the Data Query Guide. And so this included an access to something called the Common Clinical Data Set, gave a bit of guidance on the use of Smart on FHIR, which is a authorization approach to connect directly into EHRs. And while the government in the US did not require support for this guide, many developers chose this guide to implement in their system. And Apple actually used this guide to connect with hundreds of EHRs around the country. And so for folks who download things using HealthKit in the US marketplace, this content guide is what guides Apple and the EHR vendors. Now, when the work with Argonaut, was, quote, done, never really done, work is always improving, you're always taking new feedback, it was handed over to HL7 and validated through something called the US FHIR Core. So the core pieces of Argonaut are now a formal standard at HL7. And US FHIR Core is intended to be a baseline set of profiles that every EHR implements, that other use cases, whether it's for payment, for quality, for public health, are able to reuse in their use case. So it's not just for direct patient access, but is intended to be a foundational layer for other projects to build on. So Argonaut, as a private initiative, got the ball rolling. Once their work had come to agreement, it was migrated and validated at HL7 through US Core. So you can think of US Core as built from the Argonaut requirements. There was a prior effort to Argonaut called the Data Access Framework. And so, almost US Core can be thought of like the third iteration. And that had some support from the US government. But ultimately, it was the Argonaut private sector initiative that really got the work to take off. A quick comparison of what's in the Argonaut US Core guide versus the Argonaut versus US Core. So Argonaut had about 17 profiles, and the US Core added another 10 through kind of additional stakeholder feedback and some additional regulation that came out. You'll see provenance resources in here as a start to give guidance on how to keep track of who authored the information or who transmitted it. There's actually guidance in here for clinical notes. If you look at the diagnostic report profile for report and note exchange, and also the use of document reference. So to go with this, there's a full data query guide. Release is 3.1.0. And the key components of that, there's an extensions, value set, operations, search parameter, and conformance component to this guide. Before I talk about that, I want to talk about profile-less FHIR. So about 5-6 years ago at HL7 International, we talked about the ability to deploy FHIR without profiles. No problem. You download the conformance statement of the server, you adjust your searches, you start communicating, life is good. And there's kind of a dream by a few folks that you wouldn't need to write profiles. What we've learned in the US marketplace is that terminology, agreement on search criteria, all these things that are part of a profile are critical for interoperability. And so my view on profile-less FHIR is it's not possible. If you want true interoperability, you got to have some agreement and work through some of those very tricky issues of how you're going to code information and exactly which fields you're going to support. So with that, I'll give you an example. So the condition resource is available in base FHIR. And in that resource, it's a place to record the patient's problems. There's all these different elements. One key element is the code element. The code element tells you the type of problem the patient has. Now in FHIR Core, there isn't an internationally accepted code system for condition.code. And so if you look at it, I just zoomed in here a bit, the code element has a binding of example. Example means it's just purely to try to give some guidance to the developer, but actually has no bearing on what is required of their system. And so people could send their own local hospital code in this, and that would meet the base FHIR standard. What US Core does is it takes it a step further and says, okay, these are the 5 elements you must support and must implement. And if you look closely on that code element, we have a binding of US Core condition. And if you were to open that, in the US, we use SNOMED as a key terminology here. We also support ICD-10, but if you're a clinical system, you must support SNOMED. Subsystems will use ICD-10 for billing. You'll also see that we have a reference to the US Core patient, so you have to support and include a patient. You have to support what type of condition it is and have a clinical status or a verification status. Must support, this S stands for must support, is a fairly tricky concept where we have a fair bit of text to give guidance in the spec underneath the general guidance section. But you can think of it as, it's a, if it's flagged as must support, your system must have the ability to capture and exchange that piece of information. So let's take a peek at the allergy and tolerance profile. So the way we set this up is we have a small bit of introductory text about the profile, a teeny bit about usage scenarios, but then we have this section that says each allergy must have this and each allergy must support this. And what this does is it helps new developers understand exactly what they need to do in prose. If you're not interested, you can skip right down to that tree view and see, okay, like one-to-one, I gotta have a patient, I gotta have the code of the substance, and I must support these other things when I have them. The other key piece that we mentioned about what the Argonauts helped is on these search criteria. We have this quick start section, and in here, we talk about what pieces shall be supported. So you say, you need to be able to get all the allergies, and this is how it's done. You get allergy and tolerance with a search a patient, and that returns all the allergy records. Other profiles have more requirements under searches. This just has the one. It also has a recommended search, a should, to search by patient and clinical status of the allergy. But you'll see this kind of combination of a little bit of prose text introducing it, the formal profile definition, and then below a guidance on search is all kind of the pattern for the profiles. But behind all this, if you dig deep, is this thing called a structured definition. And you can download that structured definition, XML or JSON, and that shows all these rules in a formal manner, which you could import into your development system to speed your development. When you look at this profile, there are links here. So these link to the terminology, to value sets that describe what codes are allowed at each of these spots. And so if I click on common substances here, this would take me to give, gives a definition of the value set. And then when I scroll down, it gives you actually the codes that are allowed here. And so you see, this is a mix of multiple code systems. So SNOMED, CT is a code system or terminology, and RX norm. And so you can see codes from RX norm. And if we scroll, this is a very big one, okay? If I scroll way down here, then you can see substances from SNOMED that then can be included in the exchange. All right, so that's just a really quick look at the allergy and tolerance profile. This is just a quick picture of the US Core patient. You'll see in here, there's kind of this little notation at the top. These items, US Core, race, ethnicity, and birth sex, are not part of the base FHIR Core standard. In the US, we have health disparities in terms of the care that's provided. And so one of the elements our government requires is we collect the race and ethnicity of the patient. That's not something that's internationally accepted to collect. And so they're formally extensions, which is a fantastic feature of FHIR, where if you don't have all the features needed in the base spec, you can create this special extension and define your own kind of snippet of rules that go with it and then require an exchange. So we require race, ethnicity, and then the patient's birth sex, and a whole bunch of other elements to support the exchange of the patient. Within the patient, there's also a quick start section. You'll see here, you can fetch the patient by their ID or identifier, identifier being a business identifier, such as the patient's MRN. Maybe if you collect passport number or a state driver's license number, that could also be retrieved if it were stored using this identifier element. So within the spec, I mentioned that there's these value sets. Value sets have kind of two ways that they're included. One is a compose where you, which defines the codes that are intended to be part of the value set. And so you can see here it says include all SNOMED concepts where it is a clinical finding, and then it imports it. And in some cases, you'll see these get quite large. So this has more than 1,000 codes in it. And so you may have to run this, on your own terminology server by downloading Snowbed and running that query. And some value sets are small. And so the smoking status value set is only 8 concepts. And so we're able to directly list those 8 concepts in the spec. And so you can see those when you click on that, in that profile, you click on that link, it'll take you over there. And you can then download those concepts into your system. But in the US Core, there's over 20 value sets. This doesn't include everything that is referenced to the FHIR Core, but these are the ones that we've modified as part of the implementation guide. And so there's a terminology page, and you can see all these in one place. Very important part of the specification is called the capability statement. The capability statement describes the expected capabilities of your server. And in this case, we have, we've iterated over time to make the US Core capability statement as clear as possible. Client capability statement is a little different because we don't require too much. Just need to be able to initiate queries and about a patient, not a lot to it. Let's see if we get a screenshot here. So in the capability statement for patient, one of the things I would encourage is to be very specific about what you're going to require system support. So in here we have, shall support ID and then identifier and name. And then what we've learned is we didn't actually have requirements on these different combinations about gender and name or birthday and name and family and gender. But we've actually found, with testing that the servers or the developers, it's helpful for them to know exactly what searches they're expected to support, and so they know how to prioritize their development. FHIR has so much power in its search criteria, and not every system is going to be able to support those. And so making it clear what you want those systems to support, and then making it clear that the servers need to expose through the capability statement what their support is really what the clients need when they develop and build their apps on top of those servers. I did mention extensions, so we do have these few extensions that are part of the spec, race, ethnicity, so I'll just click on one here to show it to you. So inside the patient profile, you can see, again, these kind of special, they have kind of a special notation, and this takes a link to the actual definition of it. And so if we look at race, you'll see this is a kind of an extension structure definition. And we have, in the US, we have something called OMB category, the category of the race, and then other, detailed race. And this allows us to include that in the patient per the regulation in the US. Okay. So along with capability statements, it's important to have conformance testing. And so in the US, we're fortunate to have, as part of the regulation, there's a few different testing tools out there available. One of them is the Inferno platform provided by the MITRE Corporation with funding from our government. It has 2 editions. One is the ONC program edition, and that's the edition that any system seeking certification will use. They can try it directly online. It will test their implementation of Smart on FHIR, the OAuth authentication piece, and also will test the content profiles. The other edition, the community edition, allows you to upload your own IG. So if you have an Argentinian IG that you develop, or a Latin American or South American IG, you can load it up there and do some testing of your profiles. So there's the program edition, there's the community edition. One thing that's really neat is they also added this online resource validator. So if you were to select this, it's just a web form where you can upload the structured definition that you want to test. So you could export your patient structure definition or your vital signs structure definition, and then paste in your resource, and this will validate it per that structure definition. So you don't even have to work with the Inferno team. They've made the tools open source and given folks the opportunity to upload their own profiles. Okay. All right, so before I move on, well, we'll take a minute to think, when I think about the Argonaut and US FHIR Core experience, it's very important to engage the private sector, the folks who are developing the software, to work in collaboration with the standards development folks to make sure that the requirements, you know, that you're trying to get it it's feasible for the vendors to implement. And then lots of connectathon testing, lots of small iterations to make sure everyone is understanding as you go. We've had at least 6 connectathons on US Core and the Argonaut community, and we learn something new every single time, whether it's just making new text, you know, improving the narrative text of the specification, or actually changing and adding to the capability statement. We completely reworked the capability statement across a few versions. And actually this fall, we're doing a ballot where we're planning to do a lot of work to update, I say fall, this December in the US. We're doing a ballot to do an update on the definition of must support. We've struggled, it's hard. I'll just show you where that is because I think it may be of interest to folks. If you go into our specification underneath the guidance, there's actually a few things that are interesting here. There's guidance on clinical notes, how to get medication lists, basic provenance, a few things on DS2 to R4 conversions. But under the general guidance section, there's a whole section of how we define must support. The FHIR base specification allows some flexibility, and we've, you know, come up with our own set of rules, which we will be refining in a new release. We've continually refined this. Another piece that may be very interesting to folks is missing data. What do you do when you don't have data? And so we've written a section on how to use the data absent reason extension and what to do for different kind of coded data elements that are in the specification. There's also a few things about search syntax and, you know, how to reference profiles. So lots of good stuff here underneath the general guidance part of the specification. Okay. With that, I do like to make sure we're all, you know, when, you know, folks talk about FHIR, it's a lot of interest. How do you get discrete data elements? How do I get coded lab results and, you know, with line codes, or how do I get coded vital signs? I think it's important to step back and also think about, you know, what are you trying to accomplish? And one of the ways has helped me think about it is with my son. So in the US, you know, our son has been through a few different daycare situations. And as a result of those situations, we've gotten different types of information on our son. So the first one, so it's a little bit about this tug of data versus narrative. So the first one, this is my son, Edison. We got a lot of detail at this daycare. We knew exactly when he used the bathroom. We knew when he ate, how long he napped, when he had group time. We had all this data, when he did art, lots of information about Edison. But at the end of the day, when we picked him up at school, we didn't know how his day went. Like is Edison in a good mood? Which friends did he play with? We didn't really have any information to help with our transition of care home. At a different daycare, we got these nice narrative statements every couple of days. So this particular case, you know, it says, today after returning from our walk, Edison told us he wanted to put the boot bin away. I told him he could help if he got undressed, but he dawdled. I reminded him a couple of times if he wanted to put the boot bin away, he needed to get undressed. He chose to watch other children and roll on the floor. So eventually I let him know that I was going to invite other children to put it away. He got very upset and actually cried. We've seen similar experimental behavior from Edison. So we're working with Edison to link his actions to consequence. Edison, remember those things from the past, and so we hark back on those moments to explain why he should cooperate and do what he's asked. And so these little narrative snippets helped us understand how our son's day was, but we didn't know if he ate, we didn't know if he napped, and so we were missing kind of data piece of, you know, what were his vitals for that day, but we got this nice story. My wife and I had moved several times this year, so we actually had him in a different situation. And that situation, unfortunately, mimics some of the care that we get here. The other school provided nothing, no information. And so the way, you know, so we would have to negotiate with our two-year-old son to understand how his day was. And so with that, I know there's a lot of focus on discrete data, but I want to make sure that we remind folks through developing and deploying systems to not lose the patient's story. It's a key piece of the chart, and so the combination of discrete data and narrative helps providers provide the best care for patients. So if you're working on a national program to deploy standards, having a baseline like US FHIR Core is very helpful. It's helped enforce support consistency across several different IGs. We're still trying to work out to find the sweet spot, making sure we have good, strong restrictions for clinical care, but then also make sure we support the requirements of payment and quality and other pieces. And we're going to continue to evolve this. But the idea of having this common baseline, we believe, will lower cost of implementation in the US. And again, partnering with those technology providers and clinicians is the way that we have come to many of our agreements, and of course, collaborate with HL7 to develop those standards. With that, thank you so much. Thank you for having me, and I wish you a very good conference, and hope to meet many of you someday. Take care.